Alrighty, hello there, my name is James, and this video will be an introduction to polynomials, okay? So, this question is asking us, pick the expression that matches this description, okay? So, it's about to give us a description. A trinomial with a leading coefficient of 3 and a constant term of -5, okay? Now, what does this mean? Well, before we can understand this, you have to understand that each variable and exponents have different potentials. Okay, I like to call them potentials, okay? For example, if we have x squared versus x, okay? Now tell me, which one is always going to be the higher number? It's always going to be this one, x squared, because of the exponent, right? It's exponential growth versus this is linear, right? If you did y equals x versus y equals x squared, this one's always going to be a bigger number, okay? And that's the same for different exponents too. X to the third and x to the second. Obviously, x to the third has the potential to be much higher, right? Okay? And there's also constants. So if you did y equals, let's say, x plus 6, right? 6 is a constant, right? Constants have the lowest possible value, okay? Potential, because they're stuck. They don't really have potential, right? But this x has the potential to be any number, right? You can plug in any number for it. So it's linear. But these are exponential because they're even more potential to be higher numbers than just plain old x, okay? So now that we got that out of the way, we can better solve this problem, okay? So it's asking us a trinomial, meaning there's 3 terms, okay? Let's look at our problems below, our answers below, and see which ones have 3 terms in them. Tri means 3, kind of like tricycle, try something, I don't know. If you know chemistry, then you know tri means 3. Okay, so if we look at this, let's look at A right now. You can see that A has one term, that's 3m squared, and it has a -5. There's 2 terms in A. So obviously this is not the answer because it's asking for a trinomial. So we can cross that out, okay? You can see B, C, and D have not 1, not 2, but 3, right? Terms. So this is a trinomial. Now there's more stuff here, but let's just use kind of process of elimination, okay? 1, 2, 3, and you got 1, 2, and you got 3, okay? So these B, C, and D all have 3 terms, okay? So that's very helpful. And it's asking for a leading coefficient of 3. Let's circle 3. Now, what does that mean, leading coefficient? It's pretty much referring to the first number right here, okay? Now, if these are ordered correctly, which I'll show you how to order polynomials correctly in standard form, the first number is 3, okay? That's the leading coefficient. So, obviously, C could definitely be a possibility answer, and D could be an answer because their leading coefficients are 3. For B, the leading coefficient is a -5, okay? So that's obviously a no-go, okay? We can cross that out, and we know that's definitely not the answer. And it's asking us for a constant term of -5, okay? Let's circle -5. Okay, so which ones have a constant term? Remember, constant has pretty much no potential, right? It's just stationary. It cannot move. You cannot change a constant, right? Because it's constant. So you can see this one has a constant of -5, right? Well, this constant is 1, okay? So obviously D cannot be the answer because the constants don't match what the problem's asking. So we know C is the right answer, okay? That's a check mark. We can even box it. So much to do, okay? So C is the right answer. This is what it's looking for. A leading coefficient of 3 and a constant term of -5 right here, okay? So pretty good. Let's move on to another problem and see if we can do it. Alrighty, this is problem number 2. It's asking which polynomials are in standard form. Okay, so just like in problem number 1, I was gonna show you later on what standard form is, and I'm about to show you now. So remember, you need to know what terms, so this is one term, this is another term, what terms have the highest potential versus the lowest potential, okay? Like, let's say this, remember, so there's pretty much 3 types of terms. There's exponential, which if it has an exponent, it's already pretty much the highest potential you can get. There's just linear, which is just x. So, and there's constants, right? So let's say 6 plus 6. So try graphing like y equals x squared, try graphing y equals x, and try graphing y equals 6. You'll notice that it gets higher, the values get higher increasingly fast, right? So that's how we're gonna order our terms in standard form, okay? That's what it's called. From ascending to descending, okay? From highest to lowest. So let's look at this problem we got over here, okay? So it's a choose all answers that apply type of question. So there could be multiple answers. So for A, let's just take a look at A. It says t to the 4th minus 1. So it should go from highest to lowest. Obviously, exponents are much higher than constants. So this is a good answer. This is a appropriate answer. Let's do a little check mark too. Okay? Let's look at B. We got an exponent. Okay, so that is the highest possible thingamabobber, okay, term. Even though there's a -2, even though -2 is less than 3, let me circle 3 and -2, it's all about the variable and the exponent. Okay, so t squared, you got a t right here, which is a linear, which is kind of similar to this, okay? And you got a constant 4, okay? So it is indeed going from highest to lowest. So this is a correct answer. Okay, we can even check mark it. Let's look at this one down here. Is this a standard form polynomial? Okay, let's see if it is. Well, the first term is a linear and the second term is a constant, okay? So obviously this term does have a higher potential than this -7, so it is indeed a standard form polynomial, okay? Because it's going from highest to lowest, right? This term is definitely could be a higher number than -7, okay? Has the potential to. So the answer for this problem is A, B, and C, all right? That's standard form. Let me give you an example of something that's not standard form, okay? So that way you have some idea. So let's say you have, let's say -6 plus x to the 3rd minus 2x. Is this in standard form? Well, no, it is not in standard form. Okay, why? Well, let's actually undo that. Why is it not in standard form? Because the constant is first, right? And then an exponent. It should be ordered from highest to lowest, not any way you want to do it, right? There's order, there's rules, and you got to do it in using the right form, okay? So yeah, this is a big no-no because that -6 should go at the end, right? Constants always go at the end and exponents go always in the front, okay? Let's go do another problem. All right, this is problem number 3. It's asking us pick the expression that matches this description. A monomial of the second degree with a leading coefficient of 3. Okay, so let's circle what we know. A monomial. Wow, what an interesting word. You probably won't hear that too often. Mono means one, okay, if you didn't know that. So there you go. I'm not sure what other words have mono in them. I'm trying to think, but too late, okay? Timer's up. So it means, well, it only has one term, okay? So let's look at A through D and see what polynomials, well, what answers we have that only have one term, okay? So this has a 3n, that's one term, and it has a negative n squared. That is two terms. That is a big no. If we look at D down here, we're looking for something that has one term. Unfortunately, this has 1, 2, okay? That's two terms. It's a big no, okay? Because the question is asking us for one term, a monomial, okay? And it's asking a monomial of the second degree. Wow, what does that even mean? Well, it's asking to the second power. That's just a fancy way of saying to the second power, okay? And it's asking with a leading coefficient of 3. Okay? Meaning coefficient is the first number that's multiplied by the exponent. Okay, something like this. So like, let me give you some examples of coefficients, okay? So let's say you have 3x squared. I'm just going to give you maybe like a few numbers. Let's say you have 6x and you have 7x fourth, okay? These right here, these are coefficients, okay? This first number. So obviously you have your variable right here. You have your variable. And the thing that's multiplied to your variable is your coefficient, okay? So let's write that down. Coefficient. That's your coefficient. The number that's multiplied to your variable, okay? So leading coefficient of 3. Obviously this is 2. So this is the only possible answer, okay? B. That is the correct answer. Can you believe it? How cool is that? Okay, this one has a third degree, right? It's a monomial with a third degree and a leading coefficient of 2. So it's just flipped, just to kind of confuse you a little bit, but that's okay. We're smarter than that. Okay, let's go to problem number 4, shall we? Alrighty, this is problem number 4. It's asking us which polynomials are in standard form, okay? So we did this already, we did a problem like this already, but that's okay. The more practice, the better, right? So let's see. Let's start with A. So we have two terms here. And we have a constant as the first term. That's a big no-no. Because we have a variable right here. Variables, anything that has a variable in it should go in front of the polynomial, right? So the correct way to put this in standard form would be negative n plus 10. That would be the correct way, okay? So unfortunately, A is a big no-no. Okay, boo-hoo, sorry. Let's go ahead and look at B. We got 5n plus 3n to the third power minus 1. Now this constant is this is a good constant right here. Let me circle it and put a check mark. Okay, maybe that's not a very good check mark. Let me try again. Okay, fine, whatever. But that's besides the point. If you look at these two terms, you'll see that unfortunately they need to be switched. Why? Because the exponents always go in front of things that don't have exponents in them, okay? Anything with an exponent has higher priority, okay? Let me remove these arrows. So the correct way to rewrite this polynomial is 3n to the third plus 5n minus 1. So that is the correct way of doing it. Unfortunately, it's incorrect, so guess what we have to do? We cross it out, okay? That's what I did when I was younger. I always crossed out answers that I just didn't even want to look at them, okay? And let's look at C. We got three terms, n, 4n squared, and negative 7n to the third. Unfortunately, this is the complete opposite. This needs to be switched entirely, because higher exponents always have higher priority, right? This 7n to the third should actually go all the way into the front right here, okay? And this can stay where it is, and this n needs to go all the way to the back. Why? Because it doesn't have an exponent. Things that don't have exponents have less priority, less potential, okay? So let's rewrite this to see what the true standard form of this polynomial is. It's going to be negative, whoops, I did a little oopsie. It's going to be negative 7n to the third plus 4n squared plus n, okay? That would be the correct way to put this polynomial in standard form, okay? Unfortunately, it's a big no-no, okay? It is not in standard form. So the only option left we have is none of the above, okay? Because none of them are, unfortunately, the correct ones. Okay, so hope you learned how to better put these in standard form. As you can see, things with high exponents always have more dominance than lower exponents, and things with no exponents always go before things that have exponents. So you can just look at these three examples and see how we corrected them. But let's go do one more problem and we should be good to go. Okay, we got problem number 5. Okay, interesting. So it's asking us pick the expression that matches this description, okay? We already did something like this, but let's keep doing it. Why not, okay? It's asking a trinomial, let's underline it, trinomial with a leading coefficient of 3 and a constant term of, well, let's underline, and a constant term of -5. So we're looking for 3 things. It gave us 3 pieces of advice and it needs to match perfectly, okay? So let's go ahead and look at A. It's asking for trinomials, okay? So trinomial is a polynomial with 3 terms in it, okay? It's just a fancy, there's so many fancy words in math, oh my goodness. So let's underline all the terms. We got 1, 2, and 3, okay? This could be a possible answer. 1, 2, 3, that's 3 terms. And unfortunately, this one has 2, 1, 2, boo-hoo, okay? So this can definitely not be an answer because we're looking for trinomials, okay? Okay, so we crossed that out. Hopefully you can't see it. And we're looking for a leading coefficient of 3. So remember from, I believe, problem number 1, leading coefficient is this first number right here. And remember, coefficient is the number that's being multiplied to the variable, right? So see this m squared, the coefficient is -5, right? -5m squared. All right, and obviously this coefficient does not match 3, so this is the wrong answer. Oh my goodness, I'm sorry, you are disqualified. You are gone. You're done for, okay? So we have 2 possible answers left, B and D. Let's underline the terms for better viewing. So these are both trinomials. They both have a leading coefficient of 3, right? Let's do this. Both have leading coefficients of 3. But here's where they differ. In a constant term of -5. -5. So which one has a -5? It's this one. Oh my goodness. Can you believe it? This one has a constant of 1. I'm sorry for my arrow. So the constant is 1. This cannot be an answer. Oh my goodness. So it's gonna have to just go away, be scribbled away until nobody can ever find it again. It's gone forever in the universe of infinity. Okay. So this is the correct answer. Let's put a little check mark and we can box this bad boy. Okay. So this is the correct answer for the problem that the problem is asking us to find. Okay. I hope you found this video helpful. please leave a like, comment, subscribe, and I'll see you in the next one.